So yesterday I asked you to do these Regents questions. Now, some of them were review from stuff we've already had a test on, but just because we've already had that test does not mean you are free and clear from this stuff. So if you remember, this stuff will show up on your next chapter test. I will start off by saying we did not learn question 5 or 6. So if you struggled with question 5 or 6, that would explain it. So let's start with just the answers and I'll go over any you need. Number 1, the answer is 1. 2 is 3. 3 is 2. 4 is 3. If you did question 5, it would have been answer 1. If you did question 6, it would have been answer 4. And number 7 is 2. Other than the 2 we didn't learn, are there any you guys didn't get or want me to go over on that page?
4.
4. So most of the energy radiated to the earth. Ooh, I actually, I answered the wrong answer. You actually can't do that one either. So my mistake, that one is answer 1 and we have not learned that yet. Sorry about that.
I was right on that one.
Awesome, great.
I got it right.
I apologize. Yep, I read too fast. On the back though, we got number 8 is 4. Number 9 is 1. Number 10 is 3. 11 is wavelength, and 12 and 13 you could have crossed off. We didn't cover. Yeah, did you? So yeah, you didn't have to. We're going to just cover greenhouse effect later this week. All right, then we're on to the atmosphere page. So number 1 is 4. 2 is 3. 3 is 4. 4, 3, 5, 1, 6 troposphere. Any on that page we should go over? Number 4?
Yeah.
Yep. Number 4, the first thing I do want to say is notice how I circled troposphere. The question only asked what happens to the temperature, pressure, and water vapor concentration as we go through just the troposphere. It probably is. So just the troposphere is the ground to the tropopause. So just this layer. So we do start off at the ground at 15 degrees Celsius. And it does go, as you get higher in the atmosphere, the temperature does go down to -55. So the temperature decreases in that layer. Pressure starts at 1, gets over to about 0.25. Water vapor starts around 40 and gets practically to 0 in the troposphere. So everything decreases in the troposphere. But if you had done the whole atmosphere, you might have thought that eventually the temperature went up in the atmosphere. So that might have been it. Any others on that first side of that page? Okay, then on the back, this one was kind of a wording question. As you can see on my answer key for question 7, I had to do quite a bit of reading. So first thing it says, contains no water vapor. So I know the troposphere has water vapor and the stratosphere has a little bit of water vapor. So I cross those off. Then it says a temperature that increases. Troposphere and mesosphere decrease. So I have those crossed off. So now that truly only leaves thermosphere. And I double checked, has a pressure less than 10 to the -2. 10 to the -2 means we move that decimal point over 2 spots. 1, 2. So less than 0.1. Pressure of 0.1 would be over here. That would be any of these layers. But the only one that answers all those questions is the thermosphere. That one required a little bit of work. Number 8 is 2. Number 9 is 2. Number 10 is 1. And number 11, if this was a real Regents question, make sure you answer the question that's stated. It says, explain what happens to the temperature and pressure as he ascends to the summit and returns to his campsite. So it means he's going up the mountain and then back down. So for temperature, it decreases going up the mountain, increases coming back down the mountain. Same with pressure. So if that was a Regents question, which I don't think it would be, But if it was, make sure you tell me what happens when you go up and back down. Questions on this page? Next page then. This was pretty straightforward until we get to question 5. That one was a little sketchy. Number 1, the answer is 3. Number 2, 2. 3, 3. 4, 3. 5's here where it gets weird. It says the station model shows the weather conditions at Messina, New York at 9 a.m. on a particular day in June. What was the barometric pressure at Messina 3 hours earlier? So this number that they give us, this 002, that's not 3 hours ago, that's right this minute. So right this minute, Messina has 002, gets a 10 out front. This is right now. The barometric tendency, which is -3, well, it's really 31, but remember there's a decimal point, means the temperature has gone down 3.1 millibars in the last 3 hours. So 3 hours ago, it was 3.1 millibars higher than it currently is. So to get that answer, you add them together and you get 1003.3, which is answer 3. I will say I've also never seen one of those on the Regents, but it's fair game. It's one of those questions that would have separated the good from the great. Okay. Number 6 is 1 and 7 is 2. Any questions on that page? Are we acing these? Is that why we don't have questions? Or am I already going over the ones that you were confused about? Acing them. Awesome. All right. Number 8, the answer is fog. Number 9, it's 100% relative humidity. Quick quiz. How do I know it was 100% relative humidity, Alex?
Dew points and say.
Dew point and temperature is exactly the same. How many weather station? It says, what are the total number of different kinds of weather fronts? So that's a front, that's a stationary front, and that's a warm front. So there are 2 different fronts on this map. And then it asked, where could this cold, dry air mass have come from? Well, we know if it's dry, it's not coming from an ocean. So I got rid of these 2. And since it's cold, I knew it wasn't coming from Mexico, so I got rid of that. That left me with central Canada. This is a stationary front for 12A, 12B. Albany has 2.5 feathers, that's 25 knots. And again, temperature and dew point are the same, so relative humidity is 100%. Any questions on those? Yeah, which one, Drake?
The front isn't included.
Oh, son of a gun. I was just testing you. Yes, this is occluded. It's just testing you because this is what they do. Guys, I fell for the biggest trick in the book. Oh my gosh. This is what happens when you answer these really quickly first period at the end of lab.
Didn't you say always read them?
I did, except for if you're the teacher and you're in a hurry. So let me say, I literally fell for the biggest trick in the book for this one because I tried to do it from memory. And I'm like, oh, triangles and circles on the same line. I didn't bother looking at my reference table. Triangles and circles on the same line are occluded. Stationary, they're on the opposite sides. I literally fell for the biggest trick in the book. That's what Sam just said. And the direction it's coming from the northwest. Remember, if you just answered northwest for that, that'd be okay for the direction. You don't have to say it's from. But if you're ever confused, remember that wind stick is named for where it's coming from. Chris, you looked confused. What do you got going on?
I got.
Well, that's just wrong. Remember, never eat soggy worms. This is in the northwest corner. That might have just been, again, you knew it was north something and you didn't stop and think long enough. So yes, that's a huge mistake people make all the time too. Well, that was an embarrassing answer, Keith. Glad you guys caught my mistakes. Did anybody catch any other mistakes I made? Okay, good. A couple of days ago, I don't even know what day it is today. So Friday, we talked about the angle of insulation. Tell me what the heck the angle of insulation means. Angle of the sun. Another way of thinking about it is just how high the sun is in the sky. If the angle's low, what do we know? What can I say about stuff if the angle's low? Phoenix, if the sun's low in the sky, what do I know? I said, Phoenix, if the sun is low in the sky, what do I know? Where's this? Can you point to the sun if it would be low in the sky? Oh, that's pretty darn high. That's as high as it can get. So low is by the ground. That's a low angle. I don't have to tilt my head at all. I see it straight out. So if the sun's low in the sky, straight out, what do I know? What about the temperature? If the sun's low in the sky, straight over there? Okay, Alex. Yeah, if the sun's low in the sky, it's gonna be colder out. The lower the sun, the colder it's going to be. Like it's colder in the mornings than it is in the afternoon. So when the sun is low in the sky, it's going to be colder than when the sun is high in the sky. There's a couple things that control how high the sun is in the sky. Can you think of any of them? What are some things that change how high the sun is in the sky? And what does that mean? So you're right, you're not wrong, but us turning changes what? No, that's rotation, but I think you mean time of day. Okay, so the time of day. We know in the morning it's low, the afternoon is high, and at night it gets low again. What's another one?
Season.
The season. Hopefully you are well aware that that it's hotter in the summer. So one reason it would be hotter in the summer is because the sun's high in the sky. Colder in the winter because the sun's lower in the sky. Drake, you got the last one?
Latitude.
The latitude, wherever you are, the closer to the equator, the higher the sun's going to be. Easier to get a sunburn in Florida than it is in New York State because the sun is higher in the sky. So that's all angle of insulation. Today, we're going to focus in on duration of insulation. What's duration mean? How long? Like if I ask what's the duration of this class, it's 41 minutes, I believe. That wasn't the answer, you jerk faces. So if you guys could go to page 13, I believe, is that the one? Duration of insulation? I'm going to report you for bullying. You just told me my class is too long.
Some schools add like 12.
You're not finished, right? Like pages 1 through 10? Oh, it's the last one. Yes, put it on top. I'm sorry. I thought it was the one we worked on this morning. Sorry, I got lost in my PowerPoint. There we go. Here's the official definition of duration of insulation. Next year, yeah. $13, please. Top of page 13, duration of insulation. This, by the way, is the way the Regents defines it. The length of time the sun is over the horizon. I don't like this wording. Length of time the sun is over the horizon. Let's first talk about, do you guys know what horizon means?
Yeah.
A couple of you are doing some hand motions that leads me to believe you know what the horizon is. We can't see it great outside my window, but the horizon is, if you look straight out, it's where, what? If we end there early, we can go outside. The horizon is where the land meets the sky. So that's the horizon. It doesn't matter which way you look, it's wherever the land meets the sky. So when I say the length of time the sun is above the horizon, what's another way of explaining that phrase? Length of time the sun is over the horizon. Another way I could explain that. You got it, Alex? What's it mean? Guys, point to the horizon or where it would be. Yep, straight out. What's it mean the sun is above the horizon? Point to where that is. Anywhere above that. So what's it mean the length of time it's above the horizon?
See the sun.
It's the time we can see the sun. It's how long we can see the sun. In other words, as I put up there, it's the amount of daylight. So it's really just saying how long the sun is in the sky, how long we can see the sun, how long it's daylight. Do we always have the same length of daylight? No. What do you guys know? When do we have short days? Winter. Yeah, and by the way, when I say short days, please think of me saying short daylight. I'm gonna try and remember to say that, but if I don't, that's what I mean. So during the winter, we have short numbers of daylight hours. When do we have longer ones? Summer.
Right now.
Right now it's getting longer. We're not at our peak yet. We're not to the peak until June 21st.
The first day of summer.
It is the first day of summer. The first day of summer is the longest daylight hours of the year. The shortest is the first day of winter.
Good job.
Yeah, glad we knew that already. So, you know, one reason we have things that control how long our daylight hours are, it's the time of year, the season. There's one other thing that's gonna control whether we have longer or shorter days. Where we live. What do you guys know about if we lived up near the North Pole, let's say near Alaska, you guys?
Sometimes always light is up.
Okay, so Phoenix, why do you know that?
I don't know, just.
Do you watch any of those shows yeah, that's what I was actually going to talk about. Do you know the names of some of the TV shows?
Alaskan Bushman.
That's it. I called it just the Alaskan Bush, but it's, yeah, the Alaskan Bushman. I think there's like an Alaskan State Trooper one. Ice Road Truckers was a good example. The Last Frontier or something like that. All these are just shows that are filmed in Alaska. And what Phoenix knows about those shows is during the summer, it's daylight in some places of Alaska for 24 hours. What you also might know from those shows is in the winter, it is dark for 24 hours a day in parts. You know, I don't know how I feel about either one of them. I agree. If it was dark all day long, I wouldn't like it. But I don't know what I feel like if it was light all day long. Could you imagine going to bed like that? Especially if you had just had 24, Alex is saying I could fall asleep for that. I personally couldn't. Especially if I had just come off of having 24 hours of darkness. I don't know if I could handle this gorgeous weather and not go to bed. And it is, there is a higher number of seasonal type depressions in Alaska, more than likely associated with the daylight hours. But anyway, that's really all. You guys already know the gist of it. So let's just write in our notes here on page 13. For latitude, again, where you are and time of year are the two things that control how long the sun is in the sky. And you basically told me you knew this already. All right, so what do we have to add for this? This is one thing you might not have known, and I didn't bring it up yet. At the equator, there are 12 hours of daylight all year long. Not like us where we have short winters and long summers. For them, short daylight hours in winter, long daylight hours in summer. They're just 12 hours all year. It's kind of easy to remember this What do you know about 12 hours of daylight? It's half the day. So we have 12 hours of daylight, 12 hours of darkness. It's equal hours of daylight, equal hours of darkness, just like the word equator, EQU, equal. I guess technically EQUA. Equal hours of daylight, equal hours of darkness. So it's not like us, you know how, do you guys like those long summer days? I love them. Do you, Alex? Alex does not. I like those long summer days. You get up, the birds are chirping in your window because it's already daylight. Then it doesn't get dark until like 9 o'clock at night. Think of those like late baseball games you might have had when you were younger. It didn't get dark out until like after 8 o'clock. The lights at the field didn't turn on until 8 o'clock at night. I like that. At the equator, they don't get that. Sun rises at 6 a.m., sets around 6 p.m. No late days, like they're all the same. Now, would I like that in the winter? Yeah, I would like that in the winter, but not our summers. I'd miss our long summer days. Now, the rest you already know. Never mind, first I'm going to show you some actual data here. So this was from a couple years ago, but I'm sure it's very similar. Back in 2022 on April 1st, this is in Buffalo and this is in Fairbanks, Alaska. April 1st in Buffalo, the sun would rise at 6:57 a.m. So pretty darn early, and would set at 7:41. That's a decent chunk of time, a little more than 12 hours of daylight. In Alaska though, on April 1st, sun was rising at 7:06 their time, setting at 8:44. They already this month have a little bit less than an hour more of daylight than us in Alaska. So that sun is shining a lot. You can see just jumping from just to 1 day later. Look, they're already up to 6-ish more minutes of daylight. Yeah, Trent.
So like not on the equator where they have 12 hours all year long. Does it rise early in the morning, set early at night?
Let's look it up. Let's look it up right now. I don't think I had the equator there. Wait, let me double check. No, these were all Buffalo and New York, or Buffalo and Alaska. Sunrise time. Told you if we end early, we can. Equator, I wonder if we can get a chart. Okay, I don't know how to use that chart. That's Ecuador. I don't. What's this? Okay, that's clearly where I stole my data from the first time. Okay, let's try a couple more. What are the sunrise and sunset times on the equator? And do they change?
6:11 a.m.
So all always around 6-ish.
Oh, so you said 8.
Yeah.
Yeah.
Yeah, so 6 a.m. to 6 p.m.-ish, not exactly, but in that area, yes.
So early.
8 to 8, well, it all depends on what you gotta do, I mean. 8 to 8 would be good if you had to work all day, yeah. Yeah, I don't really care for that. I like our really long days, but again, they're better than our winters where we only get about 9-something hours, so. Speaking of, so this was April, here is This is June. On June 21st, which is the first day of summer, our sunrise is gonna be around 5:36 a.m., sunset 8:57. That's 15 hours and 20 minutes of daylight. Compared to Alaska, sunrise is going to be at 2:57 a.m. That's sunrise.
Hours of-
Yeah, and then it doesn't set again till the next day at 12:47 a.m. They have 21 hours and 49 minutes of daylight. Would it? Like, I couldn't sleep. I couldn't handle that.
For a little less than 3 hours.
Of sleep? Yeah, I barely function on less than 7, so. All right, well then you're weird. I mean, you're great. Here's winter though. Our winter, sun rises 7:43 a.m., sets at 4:44. That's 9 hours and 1 minute and 1 second of daylight. Alaska though, now this is Fairbanks, so there are places more north of this, but Fairbanks is sunrise 10:58. Guys, that was just about 20 minutes. No, it was about 10-ish minutes ago. The sun would have risen in Alaska on the first day of winter. And look at when it sets. 2:39. That's only 3 hours and 41 minutes of daylight. I couldn't handle that. You gotta get a lot done, or you just use lights. You have have some sort of electricity or kerosene lamps, depending on how far out in the bush you are. If you're living off grid. Here's the last bit, I believe, right? Just sums it up. And again, I think you know that as latitude increases, our summers, in the summer, we're gonna get longer days. So as you get closer to the North Pole, you'll get longer days in the summer, shorter days in the winter. When you're done writing this, try to answer those 3 questions, please. Got 3 questions on the bottom of the page. Guys, what's intensity mean? If something's intense, what's that mean?
Strong.
Strong. So low intensity would be weak, high intensity would be strong. Yeah, insulation, and which one are you talking about? The one is asking about the angle of insulation, not the length of insulation.
But like the higher intensity. Yeah. So the higher the angle.
Here, let's work this one through. So angle of insulation, number 1. Angle of insulation is on the x-axis, so 0 angle, that's when the sun is straight out. When the sun is just peeking over the horizon, is it strong or weak? It's weak. When the sun is just peeking over the horizon, it's going to feel cooler. You're not going to get a sunburn. It's weak when it's 0. How about if we make it up to 90 and the sun is directly over our head? Is it going to be strong or weak? Strong. The higher the sun, the stronger it is. What about if it was in the middle? Warm, in the middle, right? So in the middle, it'll be like a medium intensity. So which one of these says when it's at the ground, it's weak, when it's at the top or straight above, it's strong, and when it's in the middle, it's in the middle? Does it go back down to 0? So this is saying at 90, the intensity is low.
Three.
Yeah, so 3, it's saying when it's low to the ground, it's weak. When it's highest in the sky, it's strong, and when it's in the middle, it's in the middle.
Those are the first.
Okay, then. So number 1, the answer is 3. How's this one look? Did you already get to question 2? Yeah? Okay, so as air temperature rose slightly faster in Florida than in New York State because Florida is 2, has a higher angle of insolation. By the way, why do they have a higher angle of insolation? Because they're closer to the equator. And finally, number 3, the average temperature at Earth's North Pole is colder than the average temperature at the equator because the equator 3 receives more intense insolation. All right, that wraps up today. You have no homework. Pack up and we can go look at the horizon outside.